All right. Um, Hello, class. Gosh darn it. Oh, here I am. Okay. It's go time. Just a warning. Um, my upload is very erratic right now. So I might come and go. Hey, if you're interested, I'm thinking about a cooking live stream after the lessons today. All right. So yeah, I will most likely do a cooking live stream here. This afternoon, if anyone's interested. I'll teach you how to make bread. All right, so today we're going to talk about something called RC circuits. Okay. Maybe I'm back. Maybe I'll through this lesson. All right, so an RC circuit, I'm just going to try to blast through this. An RC circuit has a resistor and a capacitor. Let's say that the resistor has resistance R and the capacitor has capacitance C. The capacitor has charge Q naught at time 0. Okay? And what we would like to do is figure out what is the charge as a function of time. Okay? So we're going to do some node analysis. There's only one current that flows around the circuit, which I'm going to call I. All right? And so I've labeled my current. And so now I'm going to label the positive side of each resistor, or of each component. The positive side is the upstream side. Just like resistors, the same thing works for capacitors. So the upstream side is the positive side. So this would be the positive side of the resistor. This would be the positive side of the capacitor. Okay? So then I'm going to do a Kvl loop. So over C. All right, so plus Q over C. All right, so I'm going to rewrite this equation as I equals negative Q over RC. And then current is the rate of current dt over RC. And then I'm going to integrate both sides. I'm going to integrate the right-hand side from 0 to time t. And I'm going to integrate the left-hand side from Q naught to Q. Because at time t, or at time 0, we have charge Q naught. So this is a logarithmic integral. So we're going to get, for this on the left-hand side, natural log of q over q naught. Okay. And on the right-hand side, we get minus t over rc. So I can then exponentiate both sides and solve this equation. And what we get is q of t equals q naught times e to the minus t over rc. So this is our big equation for today. All right. So what this says is that the charge on the capacitor exponentially decays. All right. So this capacitor, if it starts out with some charge and we put a resistance, so the capacitor is going to discharge. The charge is going to flow through the resistor and come around and equilibrate on the other side. Okay, so this is the charge as a function of time. If we were to graph it, it would look like this: charge versus time. Going to have an exponential decay like this. Okay. How could we get the current as a function of time? Well, current equals dq dt. So taking the derivative of that would give a current of minus q naught over rc e to the minus t over rc. So this is the current as a function of time. Okay, and if we were to ask for, say, what is the energy stored in the capacitor as a function of time, well, that would be q squared over 2c. So that would be so that's going to give us q naught squared over 2c e to the minus t over 2t over rc. So that's the potential energy as a function of time. Okay, there's a request to show the equation for current. It's right here. How RC gets compared to time. So RC is called tau, which is equal to the time constant. Okay, and the time constant is the scale at which the capacitor restarted my video program, I think 8 times during that lesson, so thank